Hello, I welcome you all to this another interesting screencast, and the problem reads: determine the forces in cables AC and AB needed to hold a 20 kg ball D in equilibrium. Take F equal to 300 newtons and D equal to 1 meter. In the second case, the ball D has a mass of 20 kg. If a force of F equal to 100 newtons is applied horizontally to the ring at A, determine the dimension G so that the force in the cable AC is equal to 0. Both these problems are coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So first things first, we are going to draw the free body diagram. Great. So there we go. The ball will have some weight. It will have some weight, which we are going to indicate. We are going to have some tension force in those two chords. So let's section those chords. We'll section them here, we'll section the other one there. It doesn't matter where we section them. All we know is once we've sectioned, we're going to have opposing tension forces at the point of sectioning, according to third law by Newton, third law of motion by Newton. So there we go. We have a tension force there, right? How come I'm not drawing it well? Okay, something like that, like so. Then you are going to have another tension force there, something like so. So there we go, something like that, something like that, something like that, something like that. What else? So here down, we have is 20 kg for both, so I can indicate it. So say 20 kg times 9.81, which is the acceleration due to gravity, so that we find the weight. So 20 by 9.81, this gives us a 196.2 newtons. Okay, great. Then we are going to have two slopes here. I'll indicate them. I'll call this one as theta. Let me start with the inside one. I'll call this one as phi, and then I'll call this one as theta. Great. So we are going to have two components. We'll have this component like so, and another one in this direction like so. Okay, then we'll have another component like so, and another one in this direction like so. So let's label them. So this one is just going to be equal to these forces. I didn't indicate them. So this one is AB, and so is this one there. This one is AC, and so is this one there. And therefore, the blue is just AC cos phi, and this is AC sin phi. Okay. And then the green one, this one is AB cos theta, and this one is AB sin theta. Mind you, we have two cases there. In the first case, we are supposed to find to determine the forces AC and AB. In the second case, we are supposed to determine D. So we've drawn the free body diagram. So let's go to the first case so that we start working. Our first case is case 3-41. All right, there we go. Great. So what do we have in the first case? Mind you, we've been told in the first case that F is equal to 300 newtons. What else? We've also been told that D is equal to 1 meter. Great. So let's apply the equations of equilibrium. So we'll say summation of forces in the x equal to 0 going in this direction being our reference positive. So what we have F minus AC cos phi minus AB cos theta equal to 0. Okay. Then we have another one which is summation of forces in the y equal to 0 going up being our reference. What do we have? We have AB, AC, sine phi plus AB sine theta minus 196.2 newtons. Let me remove the unit equal to 0. So we have these two equations. So let's feed in this here. We feed in here like so. All right. So we have two unknowns. How many unknowns? Theta and phi. We can calculate this. So let's calculate what theta is. Let me calculate them on the other end there. Here. All right. Let me calculate them there. So we know that in the first case we have a triangle like this where we have theta. Then we have another one, a smaller one like so, where we have phi. And this length here is the same, it is 2 for both cases. And then this one here, it is a D plus 1.5 and the D is 1. So this is 2.5, while this one is 1.5. Okay. So we know that tan phi is just equal to 1.5 divided by 2, right? And phi therefore is just equal to, grab your calculator, okay, which is tan inverse of 1.5 over 2, which is equal to, so 1.5 divided by 2, sorry, D is 1, right? Sorry, D is 1. Where did the 1.5 come from? This is 1, this is D. Okay, so 1 like so. Okay, great. All right, so there we go, 1 divided by 2.5 and then tan that. So we get a 26.5657. Okay, so tan inverse of 0.5 is 26.57. And then theta here also is equal to 2.5. That's D plus 1.5 divided by 2. That's tan theta. Therefore, theta is just equal to tan inverse of 2.5 divided by 2. Therefore, theta is equal to, so 2.5 divided by 2. And then tan inverse of that gives us a 51.34. So we have both, we have phi equal to 26.57. We have theta equal to 51.34 degrees. All right. Is that fine? Can we wrap this? So we just wanted to have some space. So we can feed these into these and then solve these equations. we solve these particular equations. All right, so we are going to make one of these equations subject to the formula so that we solve it. So let's make AC subject to the formula. So we'll say AC is just going to be equal to F, which is a 300. Okay, it's a 300 minus AB cos theta, and theta is equal to 51.34. Then everything divided by cos phi, which is 26.57, right? So AC goes the other side. There are 300 and minus AB cos theta divided by cos phi. And replacing this, we replace this here. Okay. If we did so, then we are going to have the following. We are going to have a sine 26.57. Okay, so we have a 300 minus AB cos 51 point. Space is not enough here. Let's start from here. So we'll have we're going to have something like this. So we'll have AB, AC we said, so we'll start with sine phi, which is 26.57, and then we have a 300 minus AB cos 51.34 divided by cos 26.57, which we can take outside. Okay, we can write it here. All right, write it there. Okay, and there we say plus AB. So this we can even separate it. Okay, let's separate it in advance. So this we are multiplying by this 300 here in one point, and minus AB minus sine 26.57 divided by cos 26. Are they both sine this? Okay, yes, they are both. Okay, because it's a sine phi, this was also a cos phi. Then AB cos 51.34. Okay, then plus AB sine phi, which is 51.34, then minus 196.2 equal to 0. And therefore AB is just going to be equal to, we can find AB here. Okay, we can even come and find it down here. So find AB here equal to, let's find what AB here. We simplify this. So this becomes tan 26.57 times 300. Okay, and minus tan 26.57 no, sorry, minus 196.2. okay, and then later on we have so this gives us 46 something. Then we have divided by what do we have? minus tan 26.57 times cos 51.34 plus sine 51.34. Alright, so we have AB equal to 98. Alright, 98.55 pounds. Let me repeat this. So minus tan 26.57. This is a tan here, right? This one, okay? Tan 7 cos 51.34. Okay, plus sine 51.34. Okay, and then that goes the other side. Then we have tan. We have 196.2 minus tan 26.57. In fact, this one we say minus 300 tan 26.57 divided by answer. Okay, let's see what we get. 98.55. Great. So we have this one. Let's find what AC is equal to. Let's plug it in. So we have a 300 minus AB, which is 98.55, cos 51.34 divided by cos 26.57. So this gives us a 266.59 pounds. So 300 minus 98.55 cos 51.34 divided by cos 26.57. Alright, so we found AC and we found AB. These are the forces in the cables. So we are going to go to case number 2, which is case 3-42. Alright, so in this second case, we are being asked to find D, given that F is equal to 100 newtons and AC is equal to 0 newtons. Alright, so we are using the same equations, which are these ones here, which we can just copy. We are using these equations. We can copy. So there we go. We bring these equations here like so. So these are the two equations that we are using. So this part is 0 because AC is equal to 0 because AC is equal to 0. This part is 0 because AC is equal to 0. Okay. And then this part we've been told F is equal to 100. Alright, so rewriting this, we have the following sets of equation. We have 100 minus AB cos theta equal to 0. And then we have the other side, we have AB sin theta minus 196.2 equal to 0. Alright, so the two equations, we can write them like so. They can divide. So we'll have AB sin theta divided by AB cos theta. Then this is equal to 196.2 divided by 100. So this becomes tan theta is equal to, okay, tan theta is equal to 196.2 divided by 100, and therefore theta is equal to 196 divided by 100, and then tan inverse of that, we have theta equal to 62.99 degrees. All right, so we want to find D. So we can draw this triangle here quickly. We can do that. We want to find D. All right. So there we go. We have something like this. All right. Let's give it the dimensions quickly. So we have from that point to that point, and then up to there. Then we have this bottom part like so. Okay. So this point here is B. This point here is B. This point here is A. So this one here is 1.5, and this is D. All right. And the bottom part here is a 2 meters. All right. So now, and this angle here is theta. So we know that theta here is equal to theta here, we know that tan theta is equal to 1.5 plus D divided by 2. Okay. Therefore, our D is just going to be equal to, so we'll feed this here. Our D, therefore, you can calculate, make this subject of the formula. So we'll have tan 62.99 times 2 minus 1.5. So D is just going to be equal to 2.42 feet. Is that so? Does it make sense? D is supposed to be longer. So let me say again, tan 62.99 times 2, okay, and minus 1.5, 2.42. I think this is about it. I think so. So let me just create a boundary here. Let me create a boundary here like so, like so, like so, like so, like so, and then outline these solutions. So I have D there, D when AC is equal to 0, and then I have AC and AB. Right, I think this is about it, and I hope the video is helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye. See you in my next screencast.